Hello students, how are you? कैसे तैयारी चल रही है? Welcome to my channel. If you have not subscribed yet, please subscribe it. Today I shall discuss one more topic in solid state, that is imperfection in solids or crystal defects. We know that in case of crystalline solid there is long range order of constituent particles, that is atoms, molecules or ions have long range as well as short range order. But in actual practice it has been found that these crystals have defects inside them. These defects may be produced due to crystallization process which occurs at a very fast speed or at a moderate speed. If the crystallization process is carried out at a faster rate or a moderate rate, then there may be some defects produced in the crystal structures. But if the crystallization is carried out at a very slow rate, then single crystals may be produced. But yet in case of single crystals there may be some defects. These defects are broadly classified into two types. First one is called point defect and second one is called line defect. If in case of a crystalline solid there is deviations from ideal position in around an lattice point or atom, then this is called point defect. But if there is deviation from ideal position along a lattice point of lattice points, then this is called line defect. It is known as line defect. Here we shall discuss only about point defects. Line defects will be studied in higher classes. Point defects can be classified further into three types. First one is stoichiometric defect. First one is called stoichiometric defect. Second one is called impurity defect. And third one is called non-stoichiometric defect. Non-stoichiometric defect. In case of stoichiometric defect, the stoichiometry of the crystal is not disturbed. It is maintained. Stoichiometric defects can be classified into two types. First one is called vacancy defect. In case of vacancy defects, some lattice points, that is atoms, molecules or ions, may be missing from their original positions, which is clear in this picture. If these are the lattice points, then some lattice points may be missing. This is the vacancy. One atom is missing from their original position. In case of vacancy defect, the density of the crystal decreases. This defect is produced by heating the crystal. If we heat the crystals, then vacancy defect may be generated. Here the density of the crystal decreases. Second one is interstitial defect. In case of interstitial defect, second one is called interstitial defect. In case of interstitial defect, some constituent particles may occupy position inside the crystal lattice. For example, if this is the normal crystal lattice, then some lattice points or atoms may occupy the interstitial position. In case of interstitial defect, the density of the crystal increases. This type of defects, right, that is vacancy defect and interstitial defects, are generally found in case of non-ionic solids. But in case of ionic solids, where the electrical neutrality is maintained, these defects are known as Frenkel defect and Schottky defect. First one is Frenkel defect. This is called Frenkel defect. In case of Frenkel defect, some ions such as cations which are smaller in size may obtain the interstitial position. For example, if this is the crystal lattice, then some cations may occupy the interstitial position here, dislocated from their original position and occupy the interstitial position. In this case, the density of the crystal does not changes. Electrical neutrality is also maintained. This type of defect, that is Frenkel defect, is present in ionic crystals where the size of cation is relatively smaller than the size of anion. For example, silver chloride, silver bromide, silver iodide, zinc sulfide shows Frenkel defects. Here the size of silver ion is much smaller than the size of chloride, bromide or iodide. Similarly, the size of zinc ion is much smaller than the size of sulfide ion. So the silver ion occupies the interstitial position, or zinc ion occupies the interstitial position inside the crystal lattice. Next is Schottky defect. In this type of defect, both the cations and anions are missing from their original position. This is known as Schottky defect. This defect is present in ionic crystals in which the size of cation and anion are nearly equal. For example, sodium chloride, potassium chloride shows Schottky defect. Here the density of the crystal decreases. For example, if this is the crystal lattice, then some cation and anion may be missing. If here one cation is missing, then in order to maintain the electrical neutrality, one anion is also missing. Therefore, in this type of defect, that is Schottky defect, the density of crystal decreases. In case of sodium chloride, it has been found that there are 10 to the power 6 Schottky defects per centimeter cube of the crystal. 1 centimeter cube have 10 to the power 6 Schottky defect. Next is impurity defects. After stoichiometric defect, next is impurity defect. In this type of defect, one foreign ion occupies the interstellar position in the crystal lattice. For example, if the molten sodium chloride in molten state is mixed with strontium chloride and the mixture is crystallized. If you mix molten sodium chloride with strontium chloride and the mixture is crystallized, it has been found that some of the lattice positions occupied by sodium ion are replaced by strontium ion. For example, if sodium ion, chloride ion, sodium ion, chloride ion, and chloride ion, sodium ion, chloride ion, sodium ion, sodium ion, chloride ion, sodium ion, chloride ion. If one sodium ion is replaced by strontium ion, then one more sodium ion will be dislocated from its original position, and one vacancy will be created here in order to maintain the electrical neutrality. Since sodium has unit positive charge but strontium has two positive charge, therefore in order to maintain the electrical neutrality, one more sodium ion will migrate from its position. Therefore, here at one position there is vacancy defect and here is interstellar defect. The position of sodium ion is occupied by strontium 2+ ions. This is the example of impurity defect. So today we have discussed about imperfection in solids, that is crystal defects. Point defects have been classified into three types: stoichiometric defect, impurity defect, and non-stoichiometric defect. In case of stoichiometric defect, we have discussed there are two types of stoichiometric defect: vacancy defect and interstellar defect in case of non-ionic solids. But in case of ionic solids, in order to maintain the electrical neutrality, these are named as Frenkel defect and Schottky defect. In case of Frenkel defect, one cation occupies interstellar position inside the crystal lattice. These defects are generally found where the size of cation is much smaller than the size of anion. For example, silver chloride. In case of Schottky defect, both cation and anion are missing from their positions and there is decrease in density of the crystal. These type of defects are found where the size of cation and anion are nearly equal. For example, sodium chloride, potassium chloride shows Schottky defect. Next is impurity defect. In case of impurity defect, the lattice positions are occupied by some foreign cations. If we mix molten sodium chloride and with strontium chloride and the mixture is crystallized, it has been found that some positions of sodium ion are occupied by strontium ion. In order to maintain the electrical neutrality, one more sodium ion is missing from its original position. So here is vacancy defect. This defect is known as impurity defect. Thank you for watching my channel. Your comments are welcome. If you have any doubt in this lecture, you can write in the comment box. If you have not subscribed my channel yet, please subscribe it. Thank you once again.